Welcome to the Advantech Technical Training. In this topic, we will talk about the network communication concept. First of all, we are going to explain the basic concepts of Ethernet, including basic topology, OSI structure, TCP/IP, and MAC address. Then, we need to introduce how data is sent through the Internet by encapsulate and decapsulation. Third, network equipment is indicated such as a router, switch, bridge, hub, fiber, and power over Ethernet function. In the second part, we will represent a technique that is without cable, including wireless standards, technology, Wi-Fi standards, network mode, and some additional accessories which help build up a Wi-Fi environment with good quality. Let's talk about wired Ethernet. A local area network, LAN, is a computer network that interconnects computers in a limited area such as a home, school, computer laboratory, or office building using network media. A wide area network, WAN, is a network that covers a broad area, i.e., any telecommunications network that links across metropolitan, regional, or national boundaries using private or public network transport. It is a network of networks that consists of millions of private, public, academic, business, and government networks of local to global scope that is linked by a broad array of electronic, wireless, and optical networking technologies. This slide shows the whole network overview. As for the two blocks, one is the office local network, another one is the factory local network. The local network provides connections for its machine connecting. When the factory and office cross-region to connect each other, it will be a WLAN. The WLAN will exist in government, public buildings, colleges, business buildings, or personal homes, and devices will form the Internet. The Internet can exchange information across the WLAN if it's public. This page shows the basic topology for Ethernet connection. The general connections are bus/line, ring, or star connections. In the ring connection, we still need special equipment to help us reach this topology. In Layer 2 Management Switch from Advantech, we provide X-ring function to help customers reach ring architecture in the field site. In the real application, the Ethernet connection is far more complicated than we can imagine. Basically, it depends on the requirements for each field site. It mixes all kinds of Ethernet basic topology and also combines wired or wireless. Because the network allows multi-device to connect together, therefore, it needs some standards to define the data exchanging format. OSI model, it's defined by ISO, International Organization for Standardization. Before OSI structure, there were several standards, such as IMB, Token Ring, and AppleTalk, etc. If the IMB's PC wants to connect to each local network, that will be okay. But if it wants to connect to Apple's PC, that will be a problem. Because they use a different definition of network communication. So, using the uniform standard is good for cross-network and device communication. The OSI structure separates into 7 layers. Each layer has a different function for communication. As this slide shows each function. The physical layer is a hardware layer, such as an Ethernet cable and electronic binary signal. The data link layer defines the hardware address and the first data linking standard. Network layer used for path determination and logical addressing. The transport layer defines the end-to-end connections, reliability, and flow control. The session, presentation, and application layer is a software to UI display layer. Easily, it's to define the data display. OSI had 2 major components, an abstract model of networking called the Basic Reference Model or 7-layer model, and a set of specific protocols. However, the OSI model is an original principle, but it is not used in current network communication. The current standard is to use the TCP/IP structure. TCP/IP is based on the OSI structure and optimized from the OSI structure. As you can see, this slide shows the correspondence of both standards. TCP is Transmission Control Protocol, and IP is Internet Protocol. TCP/IP is the most important protocol in current Internet communication. Layer 1 is physical connection, which means Ethernet port and cable. Layer 2 is MAC, it is a unique combination of hexadecimal numbers for every Ethernet interface. It is not possible that 2 different Ethernet interfaces have the same MAC address unless the factory makes a mistake when manufacturing them. Layer 3 is IP. We can separate them into the static or dynamic IP. Static means this IP is fixed and manually set by the computer user. On the other hand, dynamic means IP is rented by the DHCP server. It would check if this IP is still used by the same device later. If not, the DHCP server would take the IP back and assign it to other devices. IPv4 is widely used in the past few decades, but now we are running out of IPv4 addresses. Therefore, scientists design IPv6, which is applied to more Ethernet devices. Let's learn how data transmit and receive. We did learn TCP/IP structure, so here I will use TCP/IP module to explain this process. The data, of course digital data, transmit and receive process through Ethernet. We call it encapsulation and encapsulation. For the encapsulation process, as this slide top to button, the data will path at least for encapsulation processes: application, transfer, internet, and link. At each layer, we'll add a data header to the beginning of the sending data. The transport layer will add protocol information into the header of the transport layer. The protocol is TCP or UDP. The internet layer will add IP information into the header of the internet layer. The IP includes IPv4 or IPv6. The link layer will add MAC information into the header of the link layer, and it will also add a footer at the end of the data packet. When the data through the encapsulation process will become an Ethernet packet. Ethernet communication sends the packet to another PC and receives packets from another PC to exchange data. This slide shows a simple communication, sending a hello message from a PC to BPC. As you can see from the flow, hello through the encapsulation process to become different packets in each layer. Then through the Ethernet to the target PC. Then through a decapsulation process to reduce the data to PCB. PCB will receive the hello message. Actually, reversing encapsulation is decapsulation. Ethernet communication is a series of encapsulation and decapsulation processes. Until now, we had learned the Ethernet process; those are internal processes. Now, I'd like to introduce some important network devices which are used to complete the networking communication. Let's learn some terms first. Routers perform the data traffic directing functions on the internet. And it's a layer 3 device. There is a management function OS inside. The router will learn the IP and set up an IP forwarding table. Switch is a computer networking device that connects network segments. It's a layer 2 device. Layer 2 device means switch only decapsulation to the link layer to know the MAC. Normally, the local area network is layer 2 communication. The switch will learn MAC and set up the MAC forwarding table. Bridging is a forwarding technique used in packet-switched computer networks. But nowadays, the application is decreasing, because most of the current switch has included the bridge function. So, we don't need to add any additional bridges to our network. Hub is a device for connecting multiple Ethernet devices together and making them act as a single network segment. There is no encapsulation and decapsulation process. Network interface card, NIC, to provide a network interface for device, such as computer, controller, etc. It's the best important device. Almost Ethernet devices had already built this interface. We often hear about two nouns, hub and switch, but what differences are between them? The biggest difference between hub and switch is that hub does not have a MAC table, which means data is sent from port A and other ports would receive the same data even though they are not the correct destination. In the meanwhile, a data is sent in port C, it would have a data collision between data A and C, which is called network error. In order to prevent such network errors, the switch is designed to have a MAC address table which will help to send data to the correct port. Others do not receive unexpected data due to they are not destinations. In industrial, the Ethernet cable has followed some standards. IEEE defines the IEEE 802.3 to be an Ethernet transmission standard. You can find this standard mentioned on most network devices, including Ethernet I/O, switch, or network interface card. Here is a table for the common 802.3 standards, such as 802.3, .3u, and .3z have defined the transmitting speed. 802.3x defined the communication mode. 802.3AF defines the Power over Ethernet standard. Just be noted, when we select the network device, we need to note this Ethernet standard to find the matched device and function. RJ45 cable is made of 4 pairs of twisted pair cable, which contains 8 pins. Cable with good quality usually has a shield in order to reject noise from the environment. In different categories, the maximum speed is faster and faster. Nowadays, the category becomes the 7th generation, the speed is double times that of Cat6. Decades ago, when you use an RJ45 cable to connect computers and Ethernet devices, you need a crossover cable to make communication work. Because Ethernet cable still follows the data transmission concept between TX and RX. Nowadays, although a switch would help to check if the cable is straight or crossover, engineers still need to know how to assemble straight or crossover cable. Fiber media converter is a simple networking device that makes it possible to connect two dissimilar media types, such as twisted pairs, with fiber optic cabling. They were introduced to the industry in the 1990s and are important in interconnecting fiber optic cabling-based systems with existing copper-based, structured systems. They are also used in metropolitan area network access and data transport services to enterprise customers. Fiber media converters support many data communication protocols including Ethernet, Fast Ethernet, Gigabit Ethernet, T1/E1/J1, DS3/E3, as well as multiple cabling types such as coaxial cable, twisted pair, multimode, and single-mode fiber optics. Media converter types range from small standalone devices and PC card converters to high-port density chassis systems that offer many advanced features for network management. A gigabit interface converter, GBIC, is a standard for transceivers, commonly used with gigabit Ethernet and fiber channels in the 2000s. By offering a standard, hot swappable electrical interface, 1 gigabit port can support a wide range of physical media, from copper to long-wave single-mode optic fiber, at lengths of hundreds of kilometers. A variation of the GBIC called the small form factor pluggable, aka SFP transceiver, also known as mini GBIC, has the same functionality but in a smaller form factor. Announced in 2001, it largely made the GBIC obsolete. After the SFP module, SFP Plus module supports 10 times faster than the SFP module. Compared with electric signals, optical also can be an interface of network communication. There shows the structure of fiber cable. Fiber optical interface has more advantages than an electric signal. Because the speed of optical is faster than electric signal, and good noise rejection. The cost of materials is lower. And because of the optical features, it supports longer distances than electricity. Normally, the Cat5 Ethernet cable limitation of distance is 100 m. The fibers support up to 2 km or 10 km. This slide shows the connector of fiber. There are 3 common fiber connectors, SC, ST, and LC. Normally, one fiber is used 2 wires to transmit and receive data. So it also comes with 2 connectors. So network devices don't have a fiber interface, but they can use a fiber converter to convert the electric interface to a fiber interface. We call it GBIC. There is 2 types of GBIC, one is the normal one, and another is mini GBIC. In fiber optic communications, wavelength division multiplexing, WDM, is a technology that multiplexes a number of optic carrier signals onto a single optical fiber by using different wavelengths, i.e., colors, of laser light. This technique enables bidirectional communications over one strand of fiber, as well as multiplication of capacity. An SFP interface on networking hardware is a modular, plug-and-play, slot for a media-specific transceiver in order to connect a fiber optic cable or sometimes a copper cable. 2. SFP transceivers exist supporting SONET, Gigabit Ethernet, Fiber Channel, PON, and other communication standards. At introduction, speeds were limited to 1 gigabit per second. The enhanced small form factor pluggable transceiver, SFP Plus, brought speeds up to 10 gigabit per second, and the SFP28 iteration is designed for speeds of 25 gigabit per second. 3. The SFP replaced the larger GBIC in most applications and has been referred to as a mini GBIC by some vendors. The most key information we need to know is the mode of fiber optical. How can we select the fiber? One of the concerns is fiber mode.
There are two types of modes of fiber. One is the signal mode, and another is multi-mode. The signal mode and multi-mode are the different transmitting features.
As you can see from the slide, the signal mode fiber uses a thin core to transmit the signal optical signal waves. Because the energy has more focus, so signal mode fiber supports more distance, it's up to 10 kilometers. But it costs high.
Multi-mode fiber costs lower, but it only supports 500 meters to 2 kilometers distance.
As you can see from the sample of multi-mode fiber, there allows for multi-optical wave transmitting. When we select the fiber interface, there are three features we need: concern, signal mode or multi-mode, connector, and wavelength. Fibers mode is the first thing we need to check with customers. This slide shows how fiber connects to the network device. As I mentioned before, fiber use two wires to transmit and receive data. Therefore, there are two wires, one is TX and another is RX. We just need to connect TX to RX and RX to TX, as the slide sample. And here also shows the shape of three common connectors: LC, SC, ST. The connector can be changed. We can connect the fiber between the different types of connector. RJ45 cable does not send data only but also can be an interface to provide electricity. There are three major standards: 802.3 AF, 802.3 AT, and 802.3 BT. All of them are standard to define how to provide power through RJ45 cable, but the limitations of watts are different. Passive PoE is the other kind of PoE standard. However, it cannot be compatible with other PoE standards due to the pin assignments are not the same. In the real field site, there would be lots of fiber cables inside tubes or nearby fiber devices. It is quite easy to mismatch fiber with devices. Therefore, you need a fiber container to arrange fiber cables and match every fiber and device. It also provides protection to prevent cable environment changes such as distortion, shock, vibration, pulling, humidity, etc. Power is supplied as a common mode signal over two or more of the differential pairs of wires found in the Ethernet cables and comes from a power supply within a PoE-enabled networking device such as an Ethernet switch, or can be injected into a cable run with a mid-span power supply. A mid-span power supply, also known as a PoE power injector, is an additional PoE power source that can be used in combination with a non-PoE switch. PoE splitter provides a separate data cable and power cable for a wireless access point. The PoE connection eliminates the need for a nearby power outlet. In another common configuration, the access point or other connected device includes internal PoE splitting and the external splitter is not used. In the next section, we will introduce wireless Ethernet. Please image a scenario: you are in a field site that is not allowed to connect any cable, and setting up any cable would cost you a fortune. In such a case, you need wireless communication to transfer data through the air, which had been designed a few decades ago. In the next slide, we will introduce several kinds of wireless methods which are commonly used worldwide. According to the wireless transmission distance, we can separate these into WPAN, WLAN, WMAN, and WWAN. Wireless personal area network, we have Zigbee, RF, and Bluetooth. Their transmission distance is less than 30 meters. Wireless local area network, we have Wi-Fi. It provides long distances and stronger signals to help transfer data faster. WMAN, which had been used for several years, but in the end, it has been replaced by a next-generation technique. WWAN, which is also known as 3G or 4G network, now is used by everybody as long as you have a smartphone. Advantages of wireless LAN are good for mobile devices and speed rate, but you cannot use the battery to activate devices. Another wireless technique is to extend time intervals and reduce the size of sending data. We have low power WAN, LoRa, and LTE, AK. A 4G communication, techniques which are good at long distances and long battery life, and also can be used outdoor. These slides show standards and ranges for a wireless person/local area network. Although they are from different standard, they are all less than 100 meters and provides a good speed rate to transfer data. In the latest generation of Wi-Fi technique, it provides 1 gigabit per second speed rate, which enhances data transmission to another level. In the local area network, we use layer 2 switches to connect computers, IP cameras, printers, and other Ethernet devices with each other. However, using switches means you need lots of cables, which make the field site look messy to connect every node. In a wireless environment, we can save lots of labor work to set up wired Ethernet but also achieve the same function as a wired network. Wireless is one interface for network communication. It uses the radio interface to transmit the network data. As the image right at the bottom and left corner, you can see the different radio signals. Therefore, the radio signal is normally controlled by the local government. When you want to import or export the radio device, you need to confirm the radio policy. The common one is IEEE 802.11 standard, which is normally called Wi-Fi protocol. Such as Ethernet Communication Standard 802.3, there are several types of 802.11. Here is the 802.11 family, and you can easy to compare the difference between each protocol. You can find the frequency, bandwidth, and speed are different. The latest B is 802.11n. Normally, the wireless interface card or module supports more than one 802.11 protocol. We need to concern if we need a specific protocol. Wireless communication there can be separated into three basic operation modes: ad hoc, infrastructure including basic set, and extended server. Normally, the wireless needs a wireless access point to provide a wireless signal. Such as basic set and extended server set both need AP to add to the wireless environment. As the basic service, when both PC want to communicate with each other, they will through the AP without any cable wires. The extended service set is a hyperstructure, including the cable and wireless structure into a system. This is a very common application to be used in every industrial or public place. It's popularly used to transmit cable networks and wireless networks. Ad hoc mode is such as the image shows, there is no access point that needs to add to its communication. Therefore, we only need a wireless interface card or module, then those devices can build their own wireless communication. When we talk about wireless communication, the antenna is a big issue during the setup and design phase. The wireless has been used in the antenna to transmit and receive data. Therefore, the wireless signal quality is relative to the antenna performance. There are two common antennas type, one is omnidirectional, and another one is directional. In omnidirectional types such as this picture, the omnidirectional antenna doesn't have direction limitations. It allows wireless CAM in multi-direction. But it is easy to interfere. Normally, we need to consider the metal and material of the wall, it will interfere with wireless a lot. Especially omnidirectional antenna, because we cannot control the signal direction. Another type of antenna is directional. Look at the second image, it's a directional antenna. This type of antenna doesn't allow any directional wireless signal. Only specific direction. Therefore, we can use this type of antenna to control the wireless signal direction to avoid obstacles. In addition, since its feature, the signal can be focused in one direction, so it can get high-quality signal in one direction. There is a question. How to choose the antenna is up to the application. Normally, either one can be connected to the same AP or wireless device. We need to consider the output capability, location, and coverage of the wireless device, and both antennae should be the same type. Thanks for your attention. Hope this course gave you a basic concept of network structure and how it works. If you are interested in advanced concepts and hands-on, you are welcome to join our product training courses. You will get a return with fruitful knowledge and skills. See you next time. Have a good learning day.